Hey there, great to be with you. Thanks for joining this presentation about Spring Security and the design and architectural patterns that it follows. I hope that you find these patterns to be useful for making your own applications more secure. My name is Josh Cummings, and my partner in crime in developing this presentation is Ria Stein. I really appreciate her contributions to it. We both work for VMware. We both work for VMware on the Spring Security team, along with Rob Winch and Joe Granja. And it's an absolute delight to be working on application security all day, every day. It's one of my true passions. Among other things that I do with Spring Security, at home, I'm the father of 7. And if that sounds like a complete circus, you're absolutely right. I have a 16-year-old all the way down to a 9-month-old, and it makes for a lot of activity in the house and a lot of fun and a lot of happiness. It's also a lot of fun when trying to record a presentation for Devnexus and trying to get everybody to be quiet. I also, if you and I ever meet for a cereal summit, I will pick Frosted Mini Wheats hands down. It's a perfect cereal, and I absolutely love it. So enough about me. Let's take a look at the application. If I hit the this endpoint in the application, you can see that it responds. It gives a 200, and it responds just fine. But it's unsecured. And what that means is that it doesn't know who called it. It doesn't know whether or not anybody's authorized to make that call. And it doesn't have any web application defense mechanisms. So let's go ahead and fix that by adding the Spring Boot Starter security dependency. By doing that, Spring Security and the application will be configured with reasonable defaults for the application. So let's see how this behaves differently after restarting. When I hit the endpoint now, we'll see that I'll get a 401 instead. Spring Security by default will defend all endpoints, whether they're U-generated or they're boot-generated. That's a nice, security position to come from, knowing that everything is going to be defended without you needing to further configure it. There is a question though about how am I going to authenticate? Because now it requires authentication. Is there like a default username and password for Spring Security? Well, there is a default username, but there's no default password. And this principle of being secure by default is a fundamental pattern inside of Spring Security, and you see it here as well, where we don't want to have a default password, because then if you deployed with the defaults, that wouldn't be very secure. Then bad actors could scan the internet and look for applications that are using the Spring Security defaults, using the default username and the default password. So because of that, the password is randomly generated on startup. The principle of secure by default, or the pattern of secure by default, is an important pattern for you to consider in your general application development as well. One that might not directly relate to security is how an application is configured. You can imagine an application whose database by default is an internal H2 database, because maybe that's what developers were using in the beginning when the application was first being produced. And then when it goes to production, there is a production profile to change the database to an external database. Well, the problem with this setup is it's not particularly secure, because if I accidentally deployed with the defaults, then I'd have my internal H2 database, though the in-memory one that has maybe all kinds of testing material inside of it, exposed to the outside world. Instead, I want my defaults to be the secure ones. So we could invert this and say that what's inside of our default application properties is what, if we deployed with the defaults, we would want production to look like. And then devs can go ahead and set the Spring Profiles active property to get their H2 database, instead of relying on production deployment to remember what defaults need to be set or overridden. If we take a look at another request here, we can see another pattern that Spring Security follows. If I have an endpoint that is an incorrect endpoint, one that doesn't exist, should I return a 404 or something else? Well, if Spring Security is in place, then it's not going to return a 404. Instead, it will still return a 401. This is an application of the principle of least privilege. We consider it privileged information to know whether or not an endpoint is correct. And the reason that's privileged information is because if we return a 404 here and a 401 with known endpoints, then the bad actors could use what's called an enumeration attack in order to figure out what are the good endpoints without having to be an authorized user knowing how to command the API. A similar principle to this is the way that usernames are handled in systems. Username and password pages, if you get one of them wrong, it says your username or your password is incorrect. It doesn't tell you both, so that way you don't have to know, or so that way people can't figure out what usernames are, what are correct usernames in the system. Forgot your password is starting to work similarly, which is great. In the past, forgot your password pages would also tell you whether usernames were valid or not. And so these days we do a little bit better and we say if that username exists, we've just sent an email. And that way, by having a message that is still helpful to the user, but also not helpful to hackers, allows that username to stay a privileged piece of information for the user. When you're thinking about principle of least privilege in your application, ask yourself the question, does the user need this piece of information in order to do their job? And if not, be conservative about that. Hold that information back, because you can always give that information out in future releases if it turns out to be a problem to not have given that information out. Doing the inverse is a little harder. If you have that information on your website or available to the public or to people to be able to exfiltrate, and then you find out that it's insecure to have revealed that, it's a little harder to pull that back. Great. So let's go ahead and now hop into the application and start replacing some of its configuration. I've got a configuration file here, and I'm going to replace the user detail service bean. This is one of the many beans in Spring Security that you can expose to configure to change its configuration. This is one of the hallmarks of the Spring ecosystem by and large, is bean-based configuration and its twin pattern dependency injection. This is nice from a security perspective because what I know is that when I publish this bean, Spring Security and Spring Boot will completely back off. I like to call this the last one wins principle. This bean being produced will completely replace any other user detail service bean that either Spring Security or Spring Boot would have produced for you. That's nice because you don't have to worry about, when you're thinking about security, you don't have to worry about what kinds of overrides, what kind of override rules you should be considering. You know that if you produce this user detail service, that's the law, that there isn't some other user detail service that Spring Security is trying to merge with this one. There's not, there aren't precedence rules that you're having to think about in order to decide whether or not your application is truly secure in the way that you designed it. Let's go ahead and up the logs before we restart. And then we can go ahead and see that this works, and then that'll enable us to actually see the next pattern. And if it wasn't clear, I totally recommend doing bean-based configuration yourself as well. And if you can also follow the last one wins principle, that whatever is the most specific bean, that's the one that overrides and completely replaces the others. It can simplify the security posture of your application. So now let's go ahead and try authenticating. It works again. That's great. If we check the logs, we'll get an inkling of our next pattern. We can see that in these purple values, we can see that Spring Security works off of a filter chain. It publishes to the container a set of filters. Each one has its own job that it needs to do to decide whether or not the request is secure and may proceed. Let's take a look at one of them to see how it's designed and why it's designed that way. One of the nice things about using the filter chain is it allows us to intercept every request and look at each one before allowing it to proceed. With anything else in the application, your servlets, your controllers, your services, whatever they might be, Spring Security it can stand in front of all of them and make sure that it's secure before your application has to worry about it. And one of the specific things that's nice inside of the filter chain is how it's designed with regard to something that is fairly similar to the chain of responsibility pattern. There's a request, a response, and a filter chain. And when the CSRF filter, which is the filter for cross-site request forgery defense that Spring Security provides to applications, once it determines that for its part it's secure, it can go ahead and delegate down to the rest of the filter chain. All it has to do to put the kibosh on the entire request, fail fast, and not have any other filters or any other part of the application have to worry about the rest of the request, is it just doesn't call that do filter method. So here in this if statement, you'll notice that it returns instead of calling do filter. And that gives this filter the reassurance that once it says that the request is a no-go, no other filter is going to touch this this request, and downstream filters can also have the inverse confidence that when they're looking at it, everybody up above them has said that for their part, the request is okay. Being able to stop the request and fail it fast is a nice pattern inside of security. And so when you're developing your own filters, I'd encourage you to do the same. Each filter will independently make its own decision as to whether or not, for the context that it knows about, if something is secure. If it's not, then it just doesn't delegate down to the rest of the filter chain. It just calls return. And when it is happy, it goes ahead and calls do filter accordingly. So now let's use our authentication, the authenticated user. If I take a look at this controller method, it's the controller method that we've been using, we might want to know who the authenticated user is. We can do that by pulling out the authentication from the security context holder. The security context holder contains an instance of authentication, which is an interface in Spring Security. And by calling the getName method, we're essentially getting the username. And then this way we can personalize it. It's a common thing in an application to, once you know that it's secure, to ask, well, who is it, so that I can look up their appropriate details or whatever it might be that you need to do. And the way that Spring Security does that is with this static class security context holder. How does it do that? Static classes, it seems that would be rather challenging to have a static class have request level state inside of it. Well, the way that it works is what's called the request thread local pattern. This is a nice pattern to follow when you need to separate request level data from your service and your repository layers. The first step is inside of a filter, which is another one of the filters in the Spring Security filter chain. We look up in the underlying repository wherever security contexts are stored, like maybe it's stored in the session. We look it up and then put it inside of the security context holder. Now, inside of this security context holder is what's called a thread local variable. A thread local variable is one that is isolated to that thread. So if you deposit a value in a thread local variable, only that thread will be able to see that value. And because servlets follow a single thread per request model, that means that after I call chain.doFilter, every other part of that application using that same thread will be able to look up the value inside the thread local variable and continue onward, which is why we can get away with this static value that has a static thread local instance inside of it. Then at the end of the filter chain, we go ahead and clean that up. We clear out the thread local variable so that it can be used by the next thread, the next HTTP request, or that it can be used by the next HTTP request that's assigned to that thread. If you've tried to do this with reactive, it hasn't worked because reactive does not follow the single thread per request model. Multiple threads can help service a single request. And so you need to use something different like Reactor's context in order to save that information. This is what Spring Security does in its Reactor context web filter, which you can go check out to see that pattern if that's something that you're interested in. So it's nice to know that no matter where we are in our application, so long as it's bound to the request, we can go ahead and look this up. And whatever our surrounding container is, whether it's whether it's a REST API or it's like a messaging container or something like that, we can do similar things to go populate this, and then our application can go look it up. Now, I'd be remiss if I didn't mention the flagship design pattern that is really what made Spring famous in the beginning, in my opinion, and that is how it popularized dependency injection. So we can use constructor injection, we can use setter injection. You're likely familiar with those. One thing you might not be familiar with is parameter injection. In a method, for example, in a controller method, Spring MVC has support for parameter injection, where you can specify what you need, and Spring MVC will go get it for you. And one of the things that it can go get is the currently logged in user. This is nicer than using that static value for a lot of reasons. A lot of the benefits that we get from dependency injection are numerous. A simple one is testing. The simpler that we can make to test this, the more thoroughly we can test it, and the better we can test it, the more secure an application is. And because I'm getting this, allowing the framework to get it for me, think about how this simplifies testing. I no longer have to supply a static class with a value or mock that static class or whatever I'm trying to do in order to make sure that my class is focused on the business logic. By doing it like this, I can just go construct an authentication, even mock an authentication, and send that value into my unit test. Now, Spring Security does come with support to help if you don't do this, but if you don't do that, but if we do, then we can allow the framework to do even more work for us. For example, we can ask the framework, you please compute what the username is by using that spell expression, go to the security context, call get authentication, and then call get name, and then pass that value to me. If I do that, then now from a testing perspective, I don't even need Spring Security in order to exercise the business logic. I can just pass in whatever name I have inside of my unit test, and things will work just fine. That kind of flexibility was afforded by taking advantage of the framework support for dependency injection here, specifically method parameter injection. So let's go ahead and try again. We'll use the endpoint, and it says hello Ria because we added that name into it, and so it works just great. All right, so we have a simple application and it works great. Let's go ahead and make an important change here. The application currently takes HTTP basic, which is kind of old school, and it also has some security limitations. It would be nicer to use something token-based like JOTs. We can do that by turning it into a resource server, and one of the modes that Spring Security supports is verifying JOTs via an authorization server. And so let's make these two changes. First, we change the dependency to say, please configure me as a resource server. And then here is the authorization server that I want you to use to verify those JOTs when they come in as a form of authentication. So now in the application with those two changes, instead of taking a username and password, it's going to take a token issued from an authorization server. Now, we'll see that in just a minute, but let's take a look at the final use case that we're going to cover. So imagine this location service. This is kind of poorly implemented, and we'll clean that up in a minute. But the idea here is that if we want to move like an airplane or a boat or some kind of craft, we're going to want the captain to be able to do that. So we've got this authority, and it says, hey, if you are the captain, then you can do this, otherwise you can't. So let's try and clean this up and try and configure Spring Security to support this scenario. If we imagine that this authority is something that is specific to our resource server, then it could come across as a scope inside of our JOT, but let's say, just for the sake of demonstration, that it's not. That we need to customize the way that we are deriving those authorities inside of our application. So now I'm not using username and password anymore, so I'll get rid of this bean. And instead, I'm going to use a comparable bean for resource server. Resource server uses this bean. The bean takes a JOT that's been verified, and then it can turn it into an authentication, and that authentication is what will be put into the security context holder. This bean, once it's published, will do the same thing that the other bean does, which is that this bean will cause Spring Security to back off, and it won't produce any of its defaults for how to convert the JOT into an authentication. We're still using the default implementation here, but what we're going to do is we're going to customize the way that granted authorities are produced. So let's go ahead and do that. When we want to customize behavior, one of the natural implication, or the natural ways that we want to do that, is we want to try and extend behavior. And so Spring Security has a default way to convert granted authorities. It's going to take each value in the scope attribute inside the token and turn each one of those into a granted authority. And if you're like, well, I have another thing that I need to do. I need to add this captain authority based on whatever scopes I see. Then I want to extend that behavior, but that idea would fail. The reason it would fail is because JOT granted authorities converter is final. A lot of classes in Spring Security are final, and the question often comes up: why is that the case? There are a number of benefits of doing this. When a class is final, from a security perspective, though, it's easier for you to know that you're getting all of the security goodness without having to worry about whether or not you're overriding methods correctly. It also encourages a pattern called composition. It's valuable to favor composition over inheritance, and so when it's final, then it encourages composition over inheritance. Now, in this demonstration, one thing I want you to look for is that it's entirely possible, and in fact very reasonable, to extend the behavior here without using the extends keyword. And doing this way gives us the extra security blanket of knowing that I'm using the Spring Security default. So any extra security vetting that's going on in here, I haven't lost that by trying to figure out which, by having to override methods inside of there. Inside of that, and potentially losing some of the security benefits. So let's go ahead and add our special authority. So we say if one of the scopes that came back from the authorization server was aircraft fly or it's boat sail, then we know in both of those cases that we can go ahead and add our custom authority, captain. Notice that even though JOT granted authorities is final, I was still able to extend the behavior just fine. This is also powerful for a number of reasons, like if I have to have multiple granted authority converter instances and formulate some kind of custom composition for how to merge them, I can still do that very easily by following this delegator pattern. Now, let's before we finish here, let me show a quick application example of this. Doing components inside of the front end is actually very common as well. Creating a registration component allows us to place it in multiple places. And it also allows this component to not have to be aware of the surrounding context in order to do its own job well. This is the same case with like Docker files, where you can that's inheritance, or you can use a builder, many builders as you want, in order to more powerfully compose your Docker file. In addition, there's another pattern here that I followed without really talking about it, and we're not exactly complete with doing it, and that's immutability. Spring Security uses immutability all over the place. The authentication object is immutable, and we try to make our beans as immutable as possible by using constructor injection instead of setter injection. And you'll notice that here too. When this converter comes back, this list of granted authorities is immutable, so we create a new one in order to make changes to it. So we'll do the same thing here and make this authority is immutable as well. From a security perspective, immutability is really nice. It's also valuable from a concurrency perspective and so forth. But immutability is nice for security because we know that once this is set in stone, downstream somebody can't override our security wishes and our intentions. They can't just like go add an authority after authentication is complete, and that's nice and reassuring. So let's go ahead and use this value. And by the way, having final classes and having immutable objects, those are both principles inside of the latest certification exams for JDK 11. So I think that's another testament to the importance of these two patterns and why Spring Security follows them. Great. So let's restart the application again. Now we're going to be using an authorization server in order to get our token, in order to get our authentication. So let's go in and ask for one. We'll get a token for RIA. That's interesting. Go ahead and get a token for RIA from the authorization server. And then we can go ahead and post to that location endpoint and try to change the location of our craft. We'll hand a bearer token in instead of RIA's username and password. And we'll see that she doesn't have authority because she doesn't have the appropriate scope. She's not a captain, and so she can't move the craft. But if we go ahead and get a token for our pilot and then try to do the same thing, then it works just fine. So the last pattern that that we want to look at is we want to try and clean up this last bit of code here. So this code isn't great because it's trying to evaluate security programmatically inside of the application, like post authentication. We want to try and remove this because, as you can imagine, if all of our services have to do authorization type decision making, then that's a lot harder to be able to audit from a security perspective. If security is laid in throughout the entire application, then it can be harder to know and evaluate whether or not all of your security rules are being properly enforced. So we want to remove this, and there are a few different ways there are two main different ways that we can remove it. I'm going to show you one and then encourage you to look at the repo for the other one. What I can do here is I can publish another bean. The bean that I'll publish here is the security filter chain bean, which is that filter chain that we talked about earlier. And I'm going to configure it by saying that anything that is using the location endpoint requires the authority of captain. It's nicer to put it over here because now we've declared our authorization rules outside of the services that are using them. And so the filter chain is what's doing it now instead of the application. And second, it's nice because now all of our security rules are all in one place. So having moved this out to the framework gives us a couple of great benefits. So consider declarative security before you start using the Spring Security APIs inside of your controllers and services. Take a step back and see whether or not there's a way to configure Spring Security to do it inside of its filter chain. You get the benefit of the filter chain making sure that it's correct before it gets to your service, and you have all your configuration in one place. Great. That's it for me. Those are the different security patterns that we try to follow at Spring Security. They've helped us massively over the years, and hopefully they're helpful to you today. You can catch up with me and the team at the Spring Security repo. Please also check out the repo here for the code, and love to hear, or for the code that was used during this presentation. Love to hear feedback from you, and enjoy the rest of the conference.